Hello, my lovely students. So here we have the chain rule. Last couple problems we didn't quite get to in class. So this one we see x to the eighth times the secant of 1 over x to the seventh. All right. So with trig functions, there is no way to take something inside and move it outside. There's no way to take something outside and move it inside. Where they are is where they stay. Now with our chain rule, we might end up with some extras outside, but we'll see that as it goes. So first and foremost, what we have here, well, ugh, is my computer driving me bonkers. All right. All right, is a product. Okay, so our first half of the product is that x to the eighth. The other part of the product is that secant of 1 over x to the seventh. So I need my b prime. Yeah, sorry. Oh, don't do the I won't erase game. All right, fine. I'll erase the other way. So a prime, x to the eighth, very clearly a power rule setup. So power down, 8 times x to the 8 minus 1 is 7. So there's our a prime. Now let's look at b prime here. Now the secant of, there's our chain rule setup. Ugly is the stuff inside, the 1 over x to the seventh. So let's go ahead and write that. This is a u for 1 over x to the seventh. So u prime, the 1 over x to the seventh, I'm going to rewrite that so it's x on the line, not in the denominator, to the negative seventh. So it takes practice to remember anytime you've got x on a bottom, you can move it up, change the exponent to a negative. The more you practice, the more it'll become second nature to remember to do that. Just if you're ever like thinking, oh, it'd be 7x to the sixth on the bottom, but where does the 7 go? Like, stop, time out. If you're having to ask, where does a thing go? And it's not like, where does it go in the product rule or where does it go in the quotient rule? Then strike that, rewind, rethink. So as x to the negative seventh, this we can use the power rule on. So we power down, negative 7, x to the negative 7 minus 1 will be x to the negative eighth. So our b prime, b is secant of u. So b prime is the derivative of secant, which we saw earlier today, secant tangent. So secant u, tangent u. I'm running out of room. Times u prime. So b prime is the secant of 1 over x to the seventh times the tangent of 1 over x to the seventh times u prime. Let me take all that and move it. shrink it a little. So our u prime is negative 7x to the negative 8. All right. So all that, defined A, defined B, found their derivatives, which meant we had to do some chain rule. Now we can finally go back and follow the product rule. So remember, our product rule is A with a B prime plus A prime with a B. Or you can write A, B prime, B, A prime. Like the order you write them in doesn't matter. It's all multiplication and then addition. Just as long as it's one thing stays the same, the other thing is the derivative. Okay. So I guess they wrote it as df dx, sure. So the differential notation is just a different way of saying take the derivative. It's just the differential notation is nice because it tells us what variable we're taking the derivative with respect to. And later on, when you get into calculus and when you get into Cal 2 and more importantly, Cal 3, multivariable, what you are doing a process with respect to makes a big difference. So right now it may seem like a lot of extra writing, but it's worth it to get used to it because you're going to be using it. All right, so A is x to the 8th. B prime So I knew it was a long thing with a lot of parentheses, so I put brackets around it just to be like very, yes, this matches my pattern. Plus A prime was 8x to the 7th, and B was the secant of 1 over x to the 7th. So there's our disgusting derivative. And like I said, most of the time, that's where you'd leave it. Especially with stuff inside trig functions, like there ain't no cleaning that up. But we do have one extra little interesting thing here. The x to the negative 8th and the x to the positive 8th, those are all part of a big product, so we could group them together and multiplied side by side, the exponents would add. So x to the 8th times x to the negative 8th becomes x to the 8 plus negative 8, which is x to the 0. Which equals 1. So we could rewrite the first part, since the x that are outside the trig functions cancel, the only other part is that negative 7 is a coefficient. So we could write negative 7 and then the secant and the tangent plus, and then it'd just be those two smushed side by side. They do both have that ugly secant. That could be factored, but odds are that's not going to help you that much. Maybe doing the next derivative, looking at it as a product rule instead of two product rules. No, actually probably would help. But that would be the only time I'd consider it. Most of these, though, right now, this is about practicing the rules so you understand how they work with functions that are more familiar. So when we start using the derivative as a tool, you're comfortable doing the derivative on all these different crazy functions. All right, now our last one adds on the equation of the tangent line. You're gonna have to do that sooner rather than later. You know, reasons. The other irritating thing about this is there's a minus sign there. I say irritating because if you're looking on a small screen, that minus sign is really easy to think is part of the whole division bar. So be on the lookout. WebWork is notorious for doing that. It's just the way it default typesets. And I hate it, but that's what we're stuck with. So given r of x is crazy ugly function and x sub 0 is this number 25 over 4, find the equation of the line tangent to the curve at blah. All right, so I have my x naught value. And I could, or I will need to plug that in to get the y value or function value that goes with it. But I also need to know the slope of the tangent line, which is the derivative at a particular number. So let's go ahead and jump in on that. So before we focus on the derivative, though, I am actually going to rearrange our function, because right now it's a quotient, but the top is only a constant. So we could do the quotient rule. It would work. It would give us the result, but it'd have some extra work in it because the derivative of 64 is 0. So that's like part of the top that goes away. If I rewrite it, but make my power a negative, so negative 64 times quantity negative 4x plus 9 raised to the negative second power. Well, now I've got some inside stuff and outside function stuff. So this is a chain rule setup. So the initial looked like a quotient, but we can turn most quotients into a product chain rule. But this one, that negative 64 is just a constant, so it's not even a product rule here, it's just chain rule. So our u is going to be the inside, negative 4x plus 9. And then u prime is very nicely just negative 4. So one more time, I'm going to rewrite r now in terms of u. So it is negative 64 u to the negative 2. So when I go ahead and work on r prime, I get negative 64 times power rule negative 2 u to the negative 2 minus 1, which will be negative 3. And then times whatever u prime is. Now, we're just going to fill in this stuff. So negative 64 times a negative 2 is a positive 128, because that's just a higher power of 2. Then our u, we go back, is negative 4x plus 9. But now raised to the negative third power times u prime, which was negative 4. Terribly sorry. That should have said r prime of x, because we took the u's out, we put the x's in. Okay, so cleaning it up just a tiny bit, because the 128 times the negative 4, I can do that. That is negative 512, negative 4x plus 9 to the negative third power. And that's all fine and dandy, yay formula. But rewind, the question was equation of the tangent line. we were finding the derivative so we could find the slope at the given x value. So now that I have the derivative formula, I can take my x value, plug it into the derivative, and that is the slope of the tangent line. So r prime of 25/4 equals, we still have the negative 512 times -4 times our x value, 25/4. So like that 25/4 was looking pretty ugly till you put it in and like, oh, that's why that 4 is there. All right, so -4 times 25/4, the 4's cancel, but the negative persists. So this is -25 plus 9, which is -16. Da, da, da. Okay. And then 16 is a power of 2. 512 is a power of 2. But at this point, that's all numbers. I mean, honestly, even at this point, it's all numbers. Type it on the calculator, enter, fraction, enter. Poof, what's my answer? I'm just running through it because my calculator don't do fractions. So -512 times 1 over -16 to the third. This will be negative, so we're going to end up with a positive number. All right, let me think through 512. 2, 4, 8, 16 is 2 to the fourth. 32, 64, 128, 256, 512. 512 is 2 to the ninth. So that is 2 to the 12th on the bottom, and 2 to the ninth divided by 2 to the 12th is 2 to the -3rd, which is 1/8. So just because you can do it by hand doesn't mean you should do it by hand. If I had a decent calculator, I'd have just typed it. But that 1/8, that is the slope of the tangent line. Now rewind, read the question again. What did they want? Oh, the equation of the line at this x value. So whichever way you go, the y equals mx plus b or the y minus y1 equals m times x minus x1, the formulas themselves should show up on the question. I just habitually use point slope. But in either case, I need to know the full point. All I have right now is the x value. I need to know what's the y value that goes with it. So on our original function, we want to plug in 25/4. So that is the negative of 64 over -4 times 25/4 plus 9 squared. Now we just did this thing inside. That's -16. And -16 squared is positive 256. So I have -64 over positive 256, which that's 2 to the 8th. Oh, 64 goes into 256 4 times. So this is -1/4. So when I go to my formula, y minus y1 equals m onto x minus x1, or x naught, if you will. So there's our formula with the blanks left. All right, so my point, the x value was 25/4. The y value was -1/4. And the slope was positive 1/8. So the reason I like this form is That is an equation of the line. You didn't say I had to solve it for y. Done. But on web work, it'll be like, solve it for y. So I'll go ahead and finish it out. But on the test, stop there. Don't do the extra work. Don't take the time. Go spend it somewhere else. So this is y plus a fourth equals 1/8 of x minus 25 over 32. And then I'm going to minus the 1/4, which is going to require common denominator. So we'd multiply that by 8 over 8, or just use the calculator. So y equals 1/8 of x, and then negative 25 30-seconds minus 8 30-seconds. 25 and 8 is 33. So minus 33 30-seconds. There's our equation of the tangent line solved for y. Only because web work usually asks you to do that. So a very ridiculous problem, but there it is all done. We've managed to work in an equation of a tangent line. Good practice for the week after next. I mean, randomly selected problem. All right. We will look at inverse trig on Friday. I know I'm a little too excited.